Hi guys, Mr. Gucci with the last help video for the 11.4 worksheet, ideal gas equation. We're doing problem number 11. If 1,057.7 liters of oxygen gas are consumed in the above equation, this is what we're using for problems 9 through 12. All right, so if 1,057.7 liters of oxygen gas are consumed in that equation, how many liters of water vapor will be released? Assume all gases are at standard temperature and pressure. All right, so here we go. We're going to set up a stoichiometry problem because this is essentially a stoichiometry problem as we talked about in class, and we're going to walk through how to solve it. So here we go. All right, I need more space. I'm doing all of this on one worksheet. Scroll, 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 scroll. Okay, cool. Here we go. Is that good? Is that good? Is that good? Is that good? All right, cool. Let's go. So we're doing a stoichiometry problem, right? Now I want you to think of this problem because this is still a chemical equation problem with some known amount going in and some unknown amount coming out. So let us set up the standard stoichiometry problem. This is problem number 11. So in this, what you normally have is some gram amount of A, all right, divided by the molar mass of A, all right, times a fraction with A on the bottom and B on top, all right, times the molar mass of B, and you end up with grams of B. All right, so this is basically the same kind of equation we've been dealing with for most of the year at this point. But now we got a problem, all right? Because we're not starting out with grams of A, we're starting out with liters of A. And we don't want to know how many grams of substance B we end up with. We want to know how many liters of substance B we end up with. So this kind of changes the equation for us, all right? And so instead of dividing by the molar mass, what we have to do instead is figure out how to convert liters into moles using the ideal gas equation, all right? So we have to do that, okay? Then we end up with the same fraction, all right, from the balanced equation, A on the bottom, B on top. And then we have to figure out how to get from moles back into liters, all right, in order to get liters of B. All right, now both of these things right here can be ideal gas equations. PV equals nRT, all right? And I'm definitely going to give you problems like this to test your mettle, all right? But it turns out that there are simpler ways to do this, okay? There are simpler ways to do this kind of problem. And it is this: looking out for the term, come on, STP. We're looking out for this term, standard temperature and pressure. If the gas is under standard temperature and pressure, then it turns out we don't need to use the PV equals nRT equation because we actually know what the conversion is from liters into moles. And it is this: at STP, we take liters of A and divide it by 22.4 liters per mole. Then we're going to multiply by the mole ratio, A on the bottom, B on top. And then we're going to multiply by 22.4 if we're trying to get into liters. All right, liters per mole. And then we get liters of B at the end. All right, those of you good with algebra might see that those 22.4s just end up canceling out because dividing by 22.4 and multiplying by 22.4 cancels out. I include them here because you won't always be dividing and then multiplying by 22.4. If we were starting with grams of A, then this would be dividing by molar mass. All right? And if we were going into grams of B, we'd be multiplying by a molar mass. So I'm just going to go through the steps here, set up, and do everything. All right? So in problem number 11, we have got 1,057.7 liters of oxygen gas. All right. It's at STP. So to convert into moles, we're just going to divide by 22.4. All right. Then we're going to multiply by a ratio. O2 goes on the bottom, and we're trying to convert into water vapor. H2O on top. All right. From the balanced equation, from the worksheet, we see oxygen is 25 and water is 18. So 25 on the bottom, 18 on top. And then to convert moles of H2O back into liters, we're going to multiply by 22.4 liters per mole. So I'm just going to plug this into a calculator, all right? Here I go. So I got my 1,057.7 liters of gas divided by 22.4 times 18 divided by 25 times 22.4. And I get, if I consume 1,057.7 liters of oxygen gas, I should produce 761.5 liters of water vapor. All right, there we go. Let me plug that into my equation and see if I got it right. Here we go. 761.5. Yes! Liters of oxygen gas. I did it. Mission accomplished. All right, there we go, guys. I hope this helped.